Professor Fary Ghassemlooy of Northumbria University was visiting us at Eindhoven University of Technology when we had the PhD defense of Thiago Bittencourt Cunha. It was all about optical wireless communication, and as we were citing Professor Ghassemlooy's work quite often, we had an interesting conversation. I also took the opportunity to record a podcast conversation with him. And one of the burning questions, of course, was, what is the future of LiFi, the future of optical wireless communication? Will it just serve niche markets? Or will it be a hands-on competition with the 4 billion Wi-Fi radio chips that find their way into laptops, IoT devices, smartphones, and so on? 4 billion a year. Is there a space for optical wireless communication?
As for your question, I wish the latter was true, that the OWC is a competition with RF, but that's not the case, and we always say that this is not the case. It's a technology which is very complementary, and as soon as we put the word complementary in front of the OWC, then it opens up, so what is it for then? And therefore it makes it clear that this technology, at least for now, will be useful and attractive in certain applications where RF finds it difficult to penetrate due to lack of resources, due to lack of signal penetration, and also due to health and well-being of the society, the people and plants and so on. So therefore, what are they? You can name like tunnels, hospitals, indoor environments, and so on, yes? And so on. That is where this is going to, in my opinion, will go. It's not something that's going to challenge, and it shouldn't really, because I don't think it can challenge RF. But it can work very nicely with RF.
What I like to compare this to is the situation in 1993.
Yes.
When I worked together with Joe Kahn at the University of California in Berkeley. And Joe was working on optical wireless communication. And he had, at this moment, he faced the problem that light signals do not go through the wall. And if you roll out a new network, you need to reach your customers, preferably with just one access point, because that's the cheapest. And then radio wins. So if you plan for coverage, it's radio. If you go for density, if each of us wants to have 10 gigabits per second, and next door there are also 15 people who want the same bit rate, then having this natural blockage, having the confinement of the room may be very attractive. And that was at some point in time why I believe that future atto-cellular network, as Harold Haas would call it, were a future. You take a much more humble position on optical wireless communication.
I think I'm being realistic. At the same time, it is my discipline and I need to promote it as a science. Because I am not a spokesperson for industry, what industry will do. I keep saying that because industry has such huge resources, they can look after themselves. My role as a scientist and academia is to plant the seeds of the next generations of ideas and therefore develop next generation of researchers and so on. They can explore things that industry may not wish to explore it because of their needs. We invited Joseph Kahn in 1991, myself and our dear friend Tony Buchwallis, to the first colloquium in optical wireless communication in IEE that time, which was in Faraday's lecture theatre in London. He was our first program, and they said, who should we invite? And we were familiar with their work, with Barry and so on. So who's the best person? Of course, Joseph Kahn. We contacted him, and he was brilliant. He says, of course I would like to come. And he gave a fantastic talk in 1991. And he also said that this is a technology which is going to support RF all the way. But it has features that RF don't have. And therefore, we need to promote those features. And one of the features we said that, well-being to the society. Because in my country, UK, parents doctors and so on are so concerned about RF radiation, having base station next to schools or nursery and places like this, they don't like it. They will campaign to remove it. Hospitals, you cannot use your mobiles. I'm sure it must be true, maybe in this country as well. You're not allowed to use mobile. In certain operating table, everything has got to be switched off and so on. But recently, the security has become so important, which started with manufacturing domain, where people were concerned that their data being basically compromised by sitting outside and just listening. And therefore, they were looking for alternative technology within manufacturing domain where nothing can leak out.
And I can complement that. In the Elliot project, we had initially a German car manufacturer participating. And of course, they liked a lot of radio communications with robotics, autonomous factories, autonomous robots. And they were very much afraid that if you use Wi-Fi, you just come up with a microwave oven, you open it at the same frequency, you blast 900 watts.
Absolutely.
You have to shut off the entire factory, and it costs them 48 hours to get the factory up and running again.
Yeah, and that's when we go around in the UK. And manufacturing in the UK are very interested in this technology, both the visible and infrared. But when we talk about the security of the data, they latch on immediately. They say, oh, this is wonderful, we never thought of that, yes? And therefore the industry in the UK is also looking at utilizing this. We know that we had a project with IST, it's a company in UK, which we were doing VLC-based positioning and so on. And they sold the first batch of it to health service in England, because they thought this is fantastic. We are protecting patients' record rather than blasting all these via RF and then trying to all sorts of things to protect it and so on. So already, a government showed an interest on that. Where would it lead? We don't know. That is the responsibility of the industry to promote it as much as possible. We also, it's interesting thing, we also talk to schools, because I remember, so we are an academic, and we want to promote the science and technology. When we talk to 9 years old, 10 years old, 12 years old, and 13 years old about this technology, their eyes open, they start asking questions. But when you talk about RF, they listen and their head goes down, because they cannot associate with it, they cannot see it, they cannot touch it. But when they say, well, look at the ceiling, you have your antenna. This is sort of things, I think this light will capture the imagination of next generation of researchers, where they don't have to pick up the responsibility a bit later on. Next generations those are 10 years, 12 years, 13 years old, yes?
Yeah. It would be interesting to compare that to what here in Eindhoven also the Eco Group is doing. Yeah. You want to really boost and have world records on faster and faster bit rates, which could also be an application.
Yeah, exactly. That is also something that I would like to put here. That just you point right that the optical wireless communication is very good if you have a scenario where high capacity, high density users are served. And we are for ACO is using this method to put more throughput through the optical wireless channels. We are indoor. We are also doing the terrestrial. Long distance, 5 kilometers, we go this point-to-point connection with FSO. So that is the other technology that we are using narrow beam.
Yeah. You see that as a key application as well?
Yeah, I think it's better to, all along the last 20 years, the language that our community used, and used that very effectively, was focused on high data rate. And it became a race. And group of us, we realized that maybe we should stop this race, yes? Maybe we should look at asymmetrical data rate, because there are a lot of applications where high data rate is irrelevant. And this technology can fill that gap, especially when you mix the light with camera communication, yes, where the cameras are everywhere, in your smart devices, in buildings, in cars, streets, and so on. So therefore, how do we utilize this? If you are trying to use the camera, then you're talking about low data rate. IoT allows us to enter that domain where we don't need to talk about high data rate all the time. We talk about the application using existing technology, facilities, and resources. High data rate, we leave it to people who have the infrastructure to be able to do that. Even for the researcher, not every researcher globally can afford very high speed test and measurements equipment because of the cost, just not possible. We also know that high data rate, it fits in beautifully with optical fiber communication research groups, because they can just remove the fiber, put the lens in front of it, it goes. And then we also know, just finish this, we also know that the FSO is a special breed, because FSO feeds into defense, feeds into space, and so on. That's well taken care of, and it's been around since 1960s. We are more interested down to earth level, yes.
So that's interesting if we see how optical wireless communication could fit into the 6th generation of networks, where on one hand I see the FSO links also with work being done here in Eindhoven with a company like Aircision, with the work at ECO, where we have huge bit rates, terabits per second even, and that could replace cable connections, but that's in the backbone.
Yes.
And that's not a terabit to each and every subscriber. The other part is the subscriber link.
Yes.
And apparently, Fary, that is where you're focusing more on. And there, it may be an advertisement, a strong advertisement, this is so many gigabits per second. But if you drive through London, maybe you're not buying a Ferrari to go faster.
Yes.
It's not bit rate there.
That's right.
It is power consumption, it is latency, those kind of things.
So those are the things that, once you move away from the bit rate, then you start looking at the key KPIs of 6G, yes? Data rate is one of them. You mentioned energy efficiency, spectral efficiency, and all that. So when we look at those, we say, actually, this technology, not just the visible, but infrared, you have to mix those together. If you separate the VVLC, that's, in my view, maybe it is a bit a dangerous policy. We need to combine these together, infrared and visible light. A dedicated application, for me, when it comes to the subscriber, is more I'm interested in an indoor environment. Outdoor, it has huge challenges, in my view.
You mentioned the speed race, and in all the press releases and in scientific papers on conferences, it works wonderfully. If you can talk about terabits per second or terabits times kilometers, which comes from the fiber community, and with air turbulence, it's also more or less distance multiplied by bit rate. What would be a good metric if you would rank papers? Is that bits per second per square meter density? Is that bits per joule? Or is it?
I would use a density because that goes in line with the 6G and so on. But I also need to be very careful that we separate the high speed and medium speed and low speed and link those to application. And I see in the research community globally that the language is changing. The language of how we have developed the highest data rate link and so on is changing. It's becoming more application oriented. I think the community is learning themselves by adapting this to specific needs. And I think that's what I like to see with the next generation of researchers. Like, for example, should we go in terms of transmission length, we go sub-meter, sub-centimeter, into molecular communication, into interchip communication, where light can play a fundamental and phenomenal role. And that's why, you can now talk about things that with RF will find it very, very challenging to enter, yes. And that is the sort of path that my group and our colleagues are taking, that, basically changing the course and looking at different potential and application of infrared and visible light for communication, sensing, positioning, illumination, energy harvesting. We are combining all those. I think, in my view, that VLC communication on its own, I think, is history. We are looking at integrated technology for an integrated environment with an integrated need for things, and we need to understand it in our own domain so we can take this ideas forward. It will also, I think, allow us to define new KPIs and influence things and so on, as RF has been doing for the last 110 years. Yeah. And that is our responsibility and future generation of researchers in order to get involved and promote this technology.
You mentioned also the very interesting application of very short range communication. I compared it a bit to an optocoupler, but yes, then to a decoupled optocoupler. Yes. Well, let's say wireless USB and the wireless docking applications could be very interesting there. Sure. And that's also a challenge on how to do that well?
Of course, of course. I mean, I think this is a Pandora box. The more you open it, the more you find new challenges. Like, honestly, we don't have the answer for all of those. Every time we look at the problem from a different angle, we find something else. And we have seen that time and time and again, that a lot of ideas and concepts migrated from RF to optical wireless communication. And it's okay, migration of science and ideas is good. But sometimes migration overtakes the events. In other words, we don't understand it because it came from different domain. My philosophy, my idea is that let's understanding a bit more and then start migrating ideas from other disciplines. Classical example was that when people, I remember in the cost actions, yes, we used to have a meetings that people were talking that, oh, VLC is wonderful and there is no, there are fading in also, sometimes they are referring to deep fading. Yeah, I'm saying this because they borrowed phrases and technology from RF, brought it into the VLC, and they were using the same sort of definition. When you looked at it closely, environment like this, does the channel experience deep fading? No, because there is no movement. Even there is no chaotic random movement. Even if there is a movement, it's not going to create deep fading.
And fading is very different. I remember also Joe Kahn. Photons add non-coherently, at least for many of the modulation methods that we look into. So it's not the fading at the wavelength of the light, but are very different effects. Do you think theory is mature enough for optical wireless communication?
No, not yet.
Wow, a downright no. So that will certainly lead to an interesting conversation in the second episode of this podcast with Professor Fary Ghassemlooy of Northumbria University.